Hi folks, you all hearing me? Yeah. All right, so we're recording again. And all right, so I'm gonna share my screen. Hold on. Right, and I'm gonna address some data that I tell you for the last question there. All right. So of course I already deleted by mistake the range of numbers that could be represented by 2's complement format with 16 bits. I had previously said that it was 2 to the power of 16 minus 1 to minus 2 to the power of 16 plus 2. This is incorrect. Just making sure that you all, and it's being recorded, plus 1, okay? So the range would be, of course, from from positive 65,535 to negative 65,535. Okay? So just making sure that you all see this correction here. All right? I have my face on the video so I can be sure while I make my correction for saying the wrong thing just now. All right, so 2 to the power of 16 minus 1, which would be 65,535, to negative 2 to the 16 plus 1. All right, as I say, my brain not firing this morning, so that error with the plus 2 there. I was overthinking something with the complements, okay, which I should not have thought about. All right, so just make that note there if you were taking any notes. Everybody fine with that, right? Everybody good?
Yes, sir.
Yes, sir.
All right. All right. So we move on to the next question. The sequence 0, 1, 0, 1, 0, 1, 0, 1. Right, so we have that represents a simplified floating point number format with a 1-bit sign, 3-bit exponent, and a 4-bit mantissa. Okay, so we have the number 0, 1, 0, 1, 0, 1, 0, 1. But this here is the sign. This here is the exponent, and this 4 digits here is the mantissa. Okay, the smallest value in the mantissa is 0, and the binary point is situated immediately to the left of the mantissa. So they said that the binary point is situated to the left of the mantissa. Write the decimal value that it represents. Show all working. Now there are 2 ways that we could work this out. They told us that in the mantissa, we have the decimal point here. We have 0, 1, 0, 1. What does our exponent work out to? Our sign works out to positive. Our exponent 101 is what? 101 is as a decimal number. What is 101?
So 5.
Come on. 5. Thank you. 5. Now the easiest way to do this, we could go like this. 1, 2, 3, 4, 5. So we'll put a 0 here, and then we say 1010 is equal to, right? This is 1, 2, 4, 8. 8 plus 2 is equal to 10.0. So the answer here is positive 10.0. Okay, that's the simplified way to work it out. Now let's work it out probably with a slightly more complex manner, right? But it's a slightly more complete manner. If we have the point 0.101 here, it means that this represented by a half, this represented by a quarter, this represented by 1/8, and this is represented by 1 over 16. It means that if we are working this out, we start with the 16th and we have 1 over 16 plus 0 over 8 would be 0 over 16. A quarter would be 4 over 16. And a half, but we have 0 values of it, would be 0. So you end up with 5 over 16. Now your exponent is 5. So this here is multiplied by 2 to the power of 5. What is 2 to the power of 5? 2 to the power of 5 is 32. So this is multiplied by 32. You have 16 to go into 32 twice. 5 by 2 is equal to 10.0. So in either way that you do it, the answer here ends up being 10.0. Everybody fine with that? I saw all manner of fancy decimal numbers, all kind of 0.325791. I couldn't even, I didn't even understand how you all come up with that, right? We have two methods that we could have done, right? The first method is to take the 0, 1, 0, 1, take the point and move it 1, 2, 3, 4, 5 according to the mantissa, according to the exponent. So you put a 0 there, which would end up with 1, 0, 1, 0 dot. And then this would resolve 8, 4, 2, 1. This would have resolved to 10.0. The other method is to use the half, quarter, 8, 16th and multiply it by 2 to the power of the exponent. Everybody understand how we get the value of 10? Using both our methods, we get the same answer. Using both our methods, we get the same answer. Everybody fine with this?
Yes.
All right. Okay. All right. So we're moving on to the next question. Right. So the memory address register, memory data register, and the instruction register. Okay. So the memory address register was the. Anybody wants to answer? Anybody wants to answer that for me? Memory address register will hold the what?
The memory address of the data and instructions to be read by the CPU.
Yes. Okay. So it holds the memory address of the next instruction to be read by the CPU. Right? The memory data register is pretty much the same, except it holds the
Data.
yeah, it holds the data of the next instruction to be read by the CPU. Right? So it holds the data of the next instruction to be read by the CPU. And the instruction register. Right? It holds the instruction that is currently being executed. Okay? So the instruction register holds the instruction that is currently being executed by the CPU. Okay? As opposed to the program counter, which we established did what? The program counter holds what? The list of instructions to be executed. But the instruction that is currently being executed is held in the instruction register. Okay, so that's the difference between them. We have three main stages of the instruction cycle. What are three main stages of the instruction cycle? We know that we have the fetch, decode, and execute. So fetch, decode, execute. Right? The next instruction is retrieved from the program counter. The opcode and location of the data is determined so that the operation to be done and the data is made available for the operation, right? And then the execute is that the program is, sorry, the instruction is carried out by the CPU, right? So whatever instruction, maybe it's a ALU instruction, or maybe it's a move instruction, etc. That instruction is carried out by the CPU. And that's our fetch, decode, execute cycle in terms of executing an instruction on the computer system. All right, so what is cache memory? Cache memory can increase the speed of a computer system by, right? Cache memory is special high-speed memory. Oops. A special high-speed memory that is located close to the processor that contains frequently used instructions / data so that the CPU does not waste time having to access it from RAM. So one situation where cache memory does not help to speed up a computer, right? If the instruction is, of course, not in cache memory, if an instruction / data is not in cache memory, then it does not help with executing executing it. Let me just put it data, right? Instructions. Okay, and so that was the first two questions. Actually, I think most people got this cache memory question. So, you know, most people got the 5 marks associated with this question. How was question 1 and 2 for you all as we've gone through the solutions?
Go ahead and take the break. Sweet. Nice. Take it first. Take your walk home.
Hello?
Yes, it wasn't that bad.
Wasn't that bad, right?
Yes, looking back at it, it wasn't that bad. It's just that I was just panicking for no reason.
All right. Good to know. Right, so it's Yeah, so I see that David say he might have overthought some solutions. That's fine, right? Don't hit your head over it. Again, we'll practice questions 1 and 2 going forward. All right. We have some properties of a well-defined algorithm. We want 3 of them. A well-defined algorithm does what? This is stuff that you all know now. So 3 properties of a well-defined algorithm. Anybody? A well-defined algorithm must
Give a general solution.
right, yeah, it must provide a general solution. It
Unambiguous.
must have unambiguous instructions. What else?
A finite amount of number of steps.
Right, must have a finite number of steps, and it must have a flow of control from one process to the other. All right, which means that that kind of ties in with unambiguous instructions, and it kind of talks about doing one thing at a time, one thing, taking it step by step, and you're doing, one thing until you get all the steps done, and each step must be clearly defined essentially. Okay, finite. All right, write an algorithm that accepts an integer and then prints all multiples of 7 that are less than the accepted integer. You may assume the existence of a function mod, which accepts 2 arguments and returns the remainder when the first argument is divided by the second. Now listen to how they told us mod works. Mod in this instance is not an operator. They are telling us that mod is a function. So what does that mean? That means that when we use mod in this example, we have to use mod as in x is equal to mod, right, 7, 2. What would the value of x be if I use mod as a function like this? You done? Hello?
Oh, my mic was on.
Okay, I thought you was going to answer my question. And then he turns his mic off. All right.
What was the question?
The question was, what would the value of x be if we called mod in this function format like this, where the value is 7 mod 2. So the answer in x would be
1.
1. Yeah. Right? So they're saying that if you're using mod in your solution, represent mod in this manner. Let's get a solution working. All right. So we asking for first a value. So we have integer n, comma, what else we have? Right? We want to print all multiples of 7 that are less than the accepted integer. Okay, so I, maybe we might need a variable I. Okay? All right. So you may assume the right. So what do we want to do? How do we start? The first thing that we want to do is to get a value from the user. So you could say print, enter a number. Print enter a number. And then what comes up after enter a number? We want to input I. So the value that we have, that's that original integer is the variable I. And we want to print multiples of 7 that are less than the accepted integer. So say, for instance, I entered 80 as the value for I want to print of course, values between 0 and 80 that are multiples of 7. How am I doing this? I could say, right, I could use a while over 4. Which one you all would have used? Yes, Joshua.
So I'd use a while. So like whatever number, like use a counter. Let's say n. You already have n there, and while n is less than
Right.
or equal to
So if we're using a counter, where we starting this counter out as? What number we starting this counter as?
1.
Okay, so n is equal to 1. So you say while n is what?
Less than or equal to num.
Well, n is less than or equal to num.
Say equal greater.
Oh, sorry. But do we want to have less than or equal to, or do we want to have just less than? Because they say print all multiples of 7 that are less than the accepted integer. So even if I put in 70, it shouldn't print back 70 for me.
Well, then you could put num to 0. I'll put n to 0. Just put less than. Yeah.
Right. Okay. N could stay as 1. That's fine. So while n is less than num, what do we want to do?
You could say just in whatever the same mod thing I had before. If
Same
you
one thing I have. No, you have to tell me what to put.
if you could let a number on an integer
Right.
x equal 4, right? If the mod,
Mod,
yeah,
for n,
right,
comma,
7
7
is equal to
is equal to 0. What do we want to do?
you want to like settle, or you want to print n.
Print, right, n. Okay. Is that it? What are we missing?
Or and increase the value of the counter. Yeah.
Right. So this should work here. This is adequate here. Okay. Let me see if I could put something behind this so that it doesn't, the lines don't disturb. So shapes, no, this is no fill. Right, white. Is this better to read?
Yes, sir.
So we have the integer n starting off as 1, and we say an enter a number, and we say while n is not less than I, because I is the number that we initially put in, not num, right? And if mod, when we do the mod for the number that we're currently at and 7, as long as you get a remainder of 0, you're going to print out that number. Okay, so easy 6 marks. All right, name a subject where we could probably get an easier 6 marks in an exam than this. Nobody could name it. See, everybody stays quiet. So, all right. So we have here now, consider the following algorithm where b, x, and the result are integers. I'm just jumping forward to see what they want us to do. Draw a flowchart that shows the algorithm. So we want to get a flowchart that shows this algorithm, okay? I'm going to copy this. All right, and add it to library. And so I can get my values from pictures, right? So I go to the next page and I pull this back. So we have this here, and we want to draw a flowchart that represents this algorithm. Okay? So our flowchart must always start off starting. And then we go and we read B and then read X. So if we're reading, we have to use an input-output box. And we say read B, comma, X. And then we have a decision to make. Okay, we have a decision to make, a if statement with a decision. So, and try and always use your arrowheads. Sometimes I and all forget to put in my arrowheads. All right? Closing off these things to just give myself more space. So if B, inside of this decision logic box here, I'm going to have B is less than 0 or X is less than 0. Okay? So B is less than 0 or X is less than 0. And if the answer for this is yes, if the answer for this is yes, then I do something in a process box. I have result is equal to -1. And then if the result here, if the answer here was no, then we go into a while loop. So a while loop is essentially a decision box that essentially loops onto itself until you could break out or no longer satisfy that condition. So we have our decision logic, the decision box. I don't know why I make this so big. I don't need it that large, right? We say X is greater than 0. All right, well, X is greater than 0. If X is greater than 0, if this is yes, then we want to do another process.
So you gotta put result equals 1 first.
Sorry? Oh,
Any process.
I missed that. Yeah, I missed that line. I apologize. So thank you very much. All right. So result is equal to 1. Thanks very much, Aidan. All right. And now we say result is equal to result multiplied by B. And X is equal to X minus 1. And this continues, this goes back into here. But if the result is no, breaks out, and it goes into print result, which will also meet up with what came from here, right? To and again an input-output box. Print result. And then we put end. Now notice something about the flow chart. Even though it It's a little scrappy looking. But notice something about the flow chart. There are no loose ends to the flow chart. Okay, there are no loose ends to the flow chart. The flow chart is everywhere that you go. When I went into yes here, right? If I went into yes here, it could get me to print result and end. If I get into no here, it could get me to print result and end. All right? I know I put this line a little close here, but this here is loop for the while loop here. So that constantly loops there. Okay? Let me not have that so close. All right, so I will put it back more to here. Okay, everybody fine with this?
Yes, sir.
All right. The next question is this looking like what you did for your end of term? I ain't reached correcting number 3 yet, so is it looking like what I did for the end of term?
Well, for me, yes, sir.
All right. Yeah, so this is a whole 10 marks. Right? A whole 10 marks, which is like somewhere like 6 to 7% of your entire paper. So these kind of questions, it's really important to grab the marks on these questions. A flowchart question, you should be getting 10 out of 10 for your flowchart. Okay? And look how easy it was. Alicia, yeah, go ahead.
One question. How much marks you would lose for like not putting your stats?
For not putting your
Stat, like erasing
you'll
stat.
probably you'll probably lose 1 mark for the start and 1 mark for the end. Listen. Okay. All right. So, and look at, I forgot to put in this result line here. Eden had to remind me. So, it's very easy to lose concentration and not do what you're supposed to do with your flowchart or something. So, all right. So they say here, write the value that is printed if b is equal to 3 and x is equal to 3 at the start of the algorithm. I'm going to do what I did before and just copy in the code here so we could follow along with it, right? Because this is the code that they're talking about here. So if b is equal to 3, and this is where we can use a truth table. We could use a truth table. You can say b is 3. So we have the variable b, we have the variable x, we have the variable result. Okay. If b is equal to 3 and x is equal to 3 at the start of the algorithm, what is the value that is printed? Okay, what you do is that you go through. So b was 3, x is 3. If b is or x is less than 0, right? If b is less than 0 or x is less than 0, result is equal to -1. So what is the value of result? Sorry, what is the value of b and x? Is either of them less than 0? No, it's not. So we have to go into the else. We start off with result being 1. While x is greater than 0, while x is greater than 0, result is equal to result multiplied by b. So result is going to be equal to result multiplied by b. So result turns to 3 and x goes down to 2. We go up, is x greater than 0? Yes. So result is equal to result by b. So result is 3, b is 3, 3 by 3 is 9, X is going to go down to 1. Right? We come back up. Is X greater than 0? Yes, it is. So result is equal to 9 by 3, which is 27. X goes down to 0. We check. Is X greater than 0? No, it's not. So print result. What's the value of result here? The value of result is 27. Write the value that is printed if B is equal to 3 and X is equal to 0 at the start of the algorithm. We're going through again. Read B. So B is now equal to 3. So we have B, X, and result. B is equal to 3 to start. X is equal to 0 to start. If B is less than 0, right, or X is less than 0, then result is equal to -1. Is B less than 0? No, it's not. Is X less than 0? No, it's not. Right? X is 0, but it's not less than 0. So we go to the else, and the else says that result is equal to 1 to start off with. While X is greater than 0, begin. Is X greater than 0? No, it's not. So we go down to end and we print result. So what is result? Result is 1. Everybody understand what we did here? Does everybody understand what we did here?
Yes, sir.
All right, so I'm going to pause here for today because I have to, my wife has a class starting now. I have to get back to what this curriculum officer wants. We're gonna continue on with this paper from next class, right? Hopefully more of you are gonna be there before I finish. Any of you all, I'm gonna stop recording now. Any